And to get closer to the real world, Jay, you've talked about the need for replication, the second scientific revolution, where you're shifting the standard of truth from publication in top journals to really success in replication. Operationally, can you share something as to how are you bringing about the sea change within NIH?
And the NIH is the lever to do that, right? So let me just say a couple of notes about this. So first, when I say replication, I don't just mean the narrow replication of one idea. I publish a paper and someone tries to find the same answer using the same data, right? That's one version of replication. It's important. But also other people looking at the same problem from a different angle, do they find the same thing, right? Does the result generalize to other populations? All of these are part of replication. There's a whole science of meta-analysis that's actually fundamentally connected to this. Two distinct approaches. One which I think is just wrong-headed and one that I think has a chance of success. One is one of policing, where the premise is that the failure to replicate results has to do with essentially fraud on the part of scientists or other groups. The evidence for this is that there are these high-profile examples of scientific fraud, where prominent scientists, prominent leaders in academic medicine have fallen from grace because the figures that they had have been manipulated in their scientific papers, or they fake scientific data or whatnot. This includes, by the way, at the NIH, major examples of the scientific fraud. Major leaders of the NIH fallen from grace as a result of the scientific fraud. The president of the university where I formerly was at also had to step down in part because of this. And so the case is that, well, we just have to police scientific fraud and it will solve the problem of replication, because failure to replicate is because really just fraud. The other approach, not this sort of anti-fraud approach being one, the other approach is a culture change approach. That's the goal I have. That's the strategy I have to solve the replication crisis, to fundamentally transform the culture of science into the collaborative enterprise it's supposed to be, where if someone fails to replicate my result, it isn't an indictment on me. In fact, it's an honor that I had an idea that was worth the attention of other scientists, to make replication and failure something that's not something that's career-ending, but rather something that's a normal part of science. It's impossible, or all but impossible, for some scientist who wants to do replication and does it well for a living, again, replication considered broadly, not just narrow replication, for a living, to make a scientific career out of it. There's very few examples of successful careers I can point to that, of people like that. And that happens in part because the NIH tends not to fund researchers who want to do that. We're going to start to fund that. And what we'll start to see then is scientists get NIH funding, will be able to get promotions at their universities, the capacity for the kind of honors that normally go to people who publish really novel science. If you think about it, replication is a form of novelty, because knowing that other people, independent people looking at the same thing, tend to find the same answer from different points of view, that's new, right? So we're going to start to fund that. One really important thing about that is I do not want the government to decide what things should be replicated. The government then could potentially be used as a weapon against new ideas, controversial ideas. I want the scientific community to determine the rate-limiting step ideas. The ideas that are the sort of pivotal, that if it turns out to be true, science moves one way. If it turns out to be false, science moves another way. We'll crowdsource that. And we'll have it in the normal same peer review structure that you've been hearing about all day, which is the most professional peer review organization in the world that the NIH has. Step 2, you cannot publish your replication studies almost anywhere. It's very difficult. Every time I ask scientists, there'll be like a couple of scientists raise their hand and say, oh yeah, I managed to publish replication. But if you're a good scientist, you're trying to do replication work all the time, and it's almost impossible to publish it anywhere. And that means you can't get credit for it. That means the rest of the world won't know about it. Actually, if you have a failed result, I mean, I've had failed hypotheses. That's my entire career. Is like I've had a whole series of failed hypotheses. And you all don't know about them because I've stuck them in my pocket because I can't publish them anywhere. Every successful scientist I know has a whole drawer full of failed results, and yet we don't talk to each other about it. It's a huge part of science that's like just left behind. We need to change the culture of science so that those kinds of productive failures are part of the scientific conversation. It's not a shame to have a failed result, especially if we can learn from it, right? And so we'll have a journal at the NIH, and I'm really bad at marketing. You can tell I'm not good at acronyms, also bad at marketing. But a journal of failed results doesn't seem like the right thing. But a journal where you can publish your replication studies, you publish your constructed failed results. One of the key things about this journal is it has to have a sort of limited gatekeeping, right? So that if someone fails to replicate my result, they should still be able to publish it. but I should be able to have a say, right? So I'll be able to like have, I as an author will be able to be a referee, and that referee report will be published along with my name about what I think about the replication. The idea is to foster conversation rather than attack each other. The third, we're introducing an Office of Meta Science that's going to start measuring scientists' productivity on a more bases than just how many papers have you published and how influential you are. That's, by the way, that is how scientists' productivity is currently measured. How influential are you? How many citations do you have to your papers? And how many and how many papers you publish? If you think about it, not a single person alive, and certainly not no scientist, really believes that those are truly the true metrics by which scientists ought to be judged. You need a broader base of metrics to judge scientific productivity. How often do you share your data with others on your published work? How often do you share your code, your tissue samples? How often are your papers subject to replication? All of these are like positive measures that encourage pro-social behavior by scientists. I think and the NIH is fully capable we're going to do all three of those things. We're going to do all three of those steps. And if we do all three of those things, I anticipate a fundamental culture shift in science. It's going to take time. Culture shifts always take time, but it is the very base of the second scientific revolution.